Hello and welcome back to Astrobitica, your home for curated space news and cosmic exploration. Here we transform the vast wonders of the universe into stories you can understand, remember, and share with others. Before we begin, take a moment to subscribe and tap that notification bell so you'll always be part of the journey beyond Earth. When most people imagine the solar system, they see that familiar classroom diagram. 8 planets lined up neatly in orbit around the Sun: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And perhaps Pluto, if you're feeling a little nostalgic. But the truth is far richer, far stranger, and far more wondrous than that simple illustration. The solar system is not a tidy row of planets, but a sprawling, dynamic neighborhood filled with moons, rings, comets, asteroids, dust, and mysteries still waiting to be solved. Some of the most fascinating places in our solar system are not even planets at all. They're moons. Take Europa, one of Jupiter's icy satellites. Beneath its frozen shell lies a global ocean, possibly containing twice the amount of water of all of Earth's oceans combined. Scientists believe there may be hydrothermal vents on Europa's seafloor, releasing heat and chemicals much like the vents in Earth's own deep oceans. And on Earth, those vents teem with life. Could Europa's hidden seas do the same? Now consider Enceladus, a small moon of Saturn. Despite its modest size, Enceladus has captured our imagination. Its surface is scattered with cracks, and from those fractures it blasts towering plumes of water vapor into space, geysers that hint at a warm, salty ocean beneath the ice. Those plumes even contain organic molecules, the building blocks of life. Every eruption is like a message whispering from a hidden ocean world. Then there's Titan, Saturn's largest moon. Titan is shrouded in a thick orange atmosphere, denser than Earth's, and its surface is carved by rivers and lakes. But these rivers are not filled with water. Instead, they flow with liquid methane and ethane, hydrocarbons filled into seas beneath the golden haze. Titan's chemistry is exotic, but it may hold clues to how life began on Earth, or how it might arise in places utterly unlike our home. These moons remind us that the search for life should not be limited to Earth-like planets. Life could exist under ice, in alien seas, or in chemical environments beyond anything we know. Between Mars and Jupiter lies the asteroid belt, a vast region filled with millions of rocky bodies, from tiny fragments to dwarf planets like Ceres. Contrary to the image from science fiction, it's not a crowded minefield where spacecraft must dodge boulders. In reality, the asteroids are separated by millions of kilometers. This belt is more like a time capsule, preserving raw material left over from the solar system's early birth. And then we come to Pluto, once the 9th planet, now classified as a dwarf planet. This was not a punishment or a demotion. Instead, astronomers refined the definition of what a planet is. Pluto still holds its wonder, with its heart-shaped plain of frozen nitrogen, mountains of water ice, and possible subsurface ocean. And Pluto is not alone. It resides in the Kuiper Belt, a frozen frontier beyond Neptune, home to countless icy bodies, dwarf planets like Ceres and Makemake, and the seeds of comets that sometimes swing inward toward the sun. But the solar system extends even farther. Beyond the Kuiper Belt lies a vast, unseen realm called the Oort cloud. Imagine a spherical shell of icy fragments surrounding the solar system, stretching nearly halfway to the nearest star. We have never observed it directly. Its existence is inferred from the long-period comets that occasionally dive toward the inner solar system, trailing luminous tails across our skies. If the Oort cloud is real, and most astronomers are convinced it is, then our solar system is far larger than we can picture. All these regions, the belts of rock and ice, the ocean worlds hidden beneath frozen crusts, the distant clouds of comets, are keys to understanding our origins. They hold evidence of how planets formed, how water and organics spread, and perhaps even where life might arise. Imagine the impact of discovering microbial life on Europa or Titan. It would mean life is not unique to Earth. Biology would not be a rare accident, but a cosmic pattern written into the chemistry of the universe. Along the way, we must also correct a few common misconceptions. Pluto was not kicked out of the solar system. It remains a fascinating class of worlds that deserve study in their own right, the dwarf planets. The asteroid belt is not a tightly packed danger zone, but a wide expanse of lonely rocks. And moons, often overlooked, can be geologically active and more promising for life than many planets themselves. In the years ahead, new missions will bring these worlds into sharper focus. NASA's Europa Clipper will soon fly to Jupiter's icy moon, scanning its surface and searching for signs of habitability. The Dragonfly mission will send a drone to Titan, hopping across its alien landscape. And future probes may one day fly through the plumes of Enceladus, sampling their spray for traces of life. These expeditions may answer one of humanity's oldest questions without leaving our own solar system. Are we alone? The solar system is not merely a backdrop for Earth. It's a vast laboratory of worlds and environments, each with its own story to tell. Some are frozen, some fiery, some familiar, and some utterly alien. Together they form a grand stage, the birthplace of Earth and the cradle of countless mysteries still waiting to be discovered. If you learned something new today about our solar system's hidden wonders, give this video a thumbs up, subscribe to Astrobitica, and tap that notification bell so you never miss our next cosmic journey. Until next time, keep looking up and stay curious.